Hey, and welcome back to Crafting a Crawler, week 9. So, I made a few changes after the last stream. So last stream we were looking mostly at our camera. So I did make a few changes to this. So what I found is that if we go to our browser for a sec. Oh, one sec. This code refuses to break properly, so it's still there lingering in the background. So do bear with me a little bit. But if we go to the graphics, graphics. There we go. Sorry. In your own time, Chrome. Oh, apparently we do have internet because we're streaming, so I'm not sure what's going on here. Oh, no, it's .org, isn't it? Okay. It seems that they are having some trouble with the wiki. Alright, well, we could probably look at the internal docs a little bit instead. So what I found, if we come, yeah, it looks like they're having a few issues. So let's come back to our code. So if we can probably have a look here. So when we attach the camera, what I found was that there is a replace transform method. So this method allows us to update a bunch of the stuff at once. Oh, the wiki is back. Let's have a quick look here. So it was replace transform. So this allows us to set a bunch of changes all at once. We set that using a transform, which comes from the love.maths or love.math package, or well, module, sorry. What we can do with this is set a bunch of properties at once. So we can set the position of the transform, the angle, the scaling factor on the x and y axis, the origin of the x and y axis, and I'm still not entirely sure what the shearing slash skew factor is. I think that it's to do with sort of diagonal squishing one side, squishing the top and the bottom of an image sort of in different directions and stuff. But yeah, with that, we're able to map some of our parameters onto those. And with that in mind, we could take the position of the camera as well as, sorry, we could take the position of the screen camera in our in terms of screen coordinates, and our position of the player in the world, and apply those to the offset and origin positions. And what this is doing is I added a constant focus, and this is just setting a vector of half and half of the screen, and that is to say that we expect the screen to be at We expect the focus of the camera to be at that proportion of the screen. I added this sort of because I could foresee some future things where we might maybe want to reuse the camera and position it somewhere, the focus somewhere else. Like maybe we have more, if we were to reuse it for a platformer, for instance, maybe we'd have more above, focus above than the bottom. So we might want to put it as sort of center screen, but we might want to center it in the screen horizontally, but like focus maybe one, like a quarter up from the bottom or 2/3 down from the top. But going back to our yeah, I also renamed the screen to viewport because that is kind of what what it actually is. It's just a name for an area that we are looking at stuff through. So by taking the position and the size of it, by taking half the size, we get the position in the middle of the screen, and we round that down or up, and that gives us that offset. And we position the transformation there. I also added angle because I don't think we're going to need it, but why not? Because it was available. We set the scale, both the X and Y scale, to be the same. I don't think we really want to squish things, or like if something is a square, we want it to stay a square. And then we take the position of the camera. And we have this method called reconfigure, and what this will do is if the dirty value is set to true, set to false, then we just stop, we return straight away, and we stop running this code right here. If not, we'll get the offset, the position, and then we'll set this transform up, and then we'll set dirty to false. And that means when we are in other methods, so rather than recreating that every time, we can create it just when things change. So when we change the position, if the new position is not equal to the old position, we set this will be true. So then if the position is different to the old position, or dirty is already true, then we set dirty to true, and then we update the position, and that will then trigger a recalculation of the transform. So we're only going to actually set that transform up when something changes, whereas previously we were doing all the math all the time. And I also added a set limits min-max. This is called if the viewport size changes, or if the limits of the map change. And the limits are now set as we now have the limits as a rectangle, and the viewport as a rectangle as well, using our rect2 class. So when we set the limit, when we make any change to the viewport or the limits, we will basically work out the minimum and the maximum point we can be in the world. So this effectively takes our viewport and calculates the X and Y positions of the corners of that of the viewport, and that is done with this edges class, which will return the left, the top, the right, and the bottom as numbers. So we'll break down the rectangle into where its sides are. So we take that, we then get a bunch of coordinates based on that are then transformed into the scale of the world itself. I'll come to this function in a sec. We then take the smallest of the x values, and we take the smallest of the y values, and that is our top corner. And then we take the largest of the x values and the largest of the y values, and that will be our right corner. And that means that if we are rotating things, we still get a bounding box that covers everything. And then we turn that into the size, and then we use that to set the basically the smallest and largest point that we can sort of get to. And this inverse focus is effectively just the reverse of the focus that we mentioned earlier. So if this was set to 0.25 and 0.25, this would be this value would be 0.75 and 0.75. So it's whatever it will add up to 1. So this is proportion down from the top left, and this is the proportion of the screen up from the bottom right. So that tells us how far into the screen we can actually move, and that made a bunch of other things easier. So the viewport and the limit are not going to change much. So that makes that all. Those values are going to be fairly stable. They're not going to change much at all. And we have to sort of reconfigure the screen to set the limit as well, just in case, because this is using this inverse transform point method, and what this does is it will transform a point from our screen coordinates. Sorry, from the game world's coordinates into the screen coordinates, and then we have there is another method that will do the opposite. So we use the transform does all the hard work of converting the points, which is where I thought it'd be handy, because then we're relying on the framework and the C code behind that to do the maths rather than having to do it in Lua itself. So yeah, so that creates the crux of things. The limit I set to a default of effectively a rectangle that is, what's that, a billion sort of pixels in each direction, which seems like a sane default. I mean, we are in we're using 32 pixels per tile, so that gives us a 31 million tile width in each direction from the start, where we start in the map before we hit a boundary. If we do want to make things infinite, chances are we're always going to be applying those bounds, but that should mean that we should be able to just create something where we're just wandering in a void or something if we decide to use any effects like that. But yeah, that was what I have added so far, and yeah, that basically made our attach method much simpler. So actually, we don't even need the check there. We can just call the method, but I'll leave it there for now. But yeah, if the screen was dirty, then we reconfigure things. And then the scissors I was looking at is a way of excluding what part of the sort of Love 2D screen that we don't want to change. So that takes a X, Y, width and height, which is exactly what our unpack method will turn the rectangle into. So we set the scissors to that, which means that nothing will get drawn outside of our viewport. which means we could effectively, if we wanted to, we could sort of have two viewports side by side if we wanted to at some point support two-player. Or we could have the viewport sort of centered in the screen if we want to put some sort of UI around it. But yeah, so that we save what was previously set. We set it to our viewport, and then we set our transform there. And on when we detach the camera, we remove the scissor. Sorry, we reset everything back to how it was before we started, and we removed the scissor. Yeah, but that gave us a couple of functions for free, effectively. So we're able to take a screen coordinate and transform that into a world coordinate. So we can take, if we want to allow any kind of mouse interaction with the world, we can do that. And we can also do the opposite of taking a world coordinate and transforming that into a screen coordinate. Yeah, that is where I sort of got to with that. I also added this size of method. So this will take the screen width and height, and then it will work out a ratio of the screen width and height, and then it will look at the it will basically find the largest whole number multiplication of the size that we request into the screen size, and then it will center our window in the middle. So this is so that if we run the game, for instance, F5, yeah, so we have our camera and it's all centered in the middle, and I've updated our window to be a sort of more standard size of proportional to a screen. But if we set the screen size to something else, this is like a, so if we go to 700, if we set the screen window to 700 and then run again, what we get now is we get a bar across the top and the bottom to ensure that everyone's always getting the same sort of size screen. And the same with the width. If we went to 1000 and we run, then we'll get some bars along either side. And this, so this was, I did this because, I did this because if we then look at the initialization, what I'm doing is I'm taking 32 by 180, which is going to be the actual resolution of our game. Oh, sorry. So I took 320 by 180 as the resolution of our game. This will scale up from here into like 1080, 1080p screens. It will go to 40p screens. It will go to 2K screens, 4K screens, 8K screens. So it will sort of give the best full screen experience for the various sort of standard resolutions, and then anyone else will get sort of top or left bars. But it also means that every pixel will be a fixed multiple of the number of pixels. I may change this at a later date. I'm not sure. Maybe it will be better to sort of squish the canvas of this screen. So maybe we fill out to the width, and you lose some. Instead, people will lose some of the visibility on the top and the bottom, or to the sides. We'll have to play with that later, but this seemed like the best sort of starting point for that. Yeah, so that was those are the changes I sort of made to the camera. Then today, I think it's probably time that we started looking at some physics. So we have a world, and we can move around that world, and we've sort of got a camera that moves around that world and tracks us around it. And we can move our player around there as well. The trouble we have though is, as we move around this world, we don't currently have a good means of keeping us where we're meant to be. So like we can sort of walk straight. We can just walk over the water. It's all the same, right? There's no collisions or boundaries in here. So I think that is what I want to look at a bit today. And we probably won't get anything major in place, but if we can start to get something, then that would be cool. So where do we start with this? There is a physics runtime built into Love2D. It's a wrapper around the Box2D library, which is used for quite a few games to do physics calculations. The thing with this though is it will be feature rich, but it will also take over a lot of how the game works. So we won't have much fine-grained control over a lot of things. So how it works is we create a world, and we put bodies into that world, and those bodies effectively have a shape, and then we can then call methods which will update the properties of those objects. So I think we would have to. So at the moment we're sort of updating our position, whereas I think what we would have to do is set an angular. No, hang on. Yeah, so we'd have to basically have a body for each entity in our world, or everything that is sort of there in the world. So walls, enemies, players, objects, etc. would all get a body. And then we would set the velocity on those. We would set a velocity on those. So I think we would. We would apply a force. force pushes body in direction. The reaction also depends on how long the force is applied. Okay, so no, for a single push that is independent of time step, it's better to use apply linear impulse. Yeah, so we would have to turn all of our, if we want to basically then move to a system where we're sort of looking at moving things around. Like if we add pathing for an enemy, we'd have to then translate that into a series of applying force to things. Apply linear. Applies an impulse to a body. This makes a single instantaneous addition to the body momentum. Yeah, so I think I mean it could work. We just have to, I'm not 100% sure how we make our enemy AI work. I mean, we can set a linear velocity as well. So maybe maybe actually we set the velocity of things. So instead of updating our position based on the velocity on each delta t, we would make sure that the linear velocity of the player is set instead, and let the and this is for spinning, I think. Yeah. So we'd set the linear velocity, and then we'd have we would get the position. We have get x and get position. So then we'd use get position to get its location for drawing. I think that makes some sense. Okay. The other option is, is that we will have to calculate the collisions ourselves. So one of where this actually comes in is if we look at our tiles. So what is one that we actually use a bunch in our map? So we have these top ones. Okay, so if we do the water ones, do we actually have it? Yeah, we don't have any path. Oh, we have one path that goes up to where the path touches water, but to begin with, we should be able to zoom this out a bit. So we should be, what we want to add effectively is these collision borders to our tiles. And then we want a thing around the player itself. So we want to take, so effectively we're going to have to go through and add we want to insert a polygon, I guess, for this one, because we want to go from there to there. If we only go for if we sort of only support square collisions, like we could also do this with math. So if instead of drawing a complex shape around this, if we sort of express it, the sort of block like that, and the idea, I think, is that these pieces would then be barriers. I think it's better to actually just do it. I think we are probably better off doing it properly, aren't we? We'll go, yeah. I think so I was thinking we could to some extent use well, to some extent abuse the fact that if we kept everything as squares, then the math to work out if something is in a square or not, sorry, if we kept everything to rectangles, the math to work out if everything is in a rectangle is actually quite simple. And we could just manually handle the collision. Yeah, we should be able to I think we'll go with the box 2D for now, and yeah, so we sort of, what we'll do is we'll define these sort of polygons around the bits that we're not allowed to step into, and these will create sort of a border. Insert a point, no, insert a polygon, that's what we're after. Yeah, so I think if we set this up, cleverly, we should also be able to switch our physics sort of implementation on at a later date. That is actually a square, isn't it? So sorry, a rectangle. I keep calling them squares today for some reason. I'm gonna blame the cold. It's definitely the cold's fault. So yeah, so we would just go in and add these into the tiles. block off this side as well. So that's the corner there. If we do these two corners, this one's done, that one's done. So I think once we've got the water ones here mostly done, then it will effectively cover most of our map. So insert a polygon here. So 1, 2, cross, diagonal, down, fill that in. We'll fix this corner. We'll do the same for this one. It's a polygon. One for this bottom corner. We will fill this side in as well. This one's a bit more complicated, but not too bad. Actually, I think that might actually be simpler than some of the other ones, to be honest. Kind of need to make sure these are all aligning as well. So I think we want to make sure that the boxes aren't sort of disjagged. Otherwise, there'll be sort of random weird little pixels you can get caught on. I think as long as on these corners they align to the outer edge of things, it should be okay. Yes, this one probably needs to come down a bit. I think with this one we will come in a little bit on the sides as well, I think. Just to give it a little buffer. This one needs to come out a bit. That doesn't look too bad. That one's alright. Let's add one for this one. Insert a polygon. Just come down across. There we go. Do the same on this side. Maybe bring this over a little bit more. This one, okay, we will insert a polygon again. I'm going to come, we came 2 in on the others, didn't we? So we'll do the same here. Is that all of them now? We have done the top row. Second row is done. Third row as well. Maybe we'll give this a little edit. It looks a little bit rough as it stands, but yeah, so I think that's okay. So that will give us that will give us a good boundary around most of our tiles. So if we save our tiles and then we export them, so when we come back to the data folder, and we have our tile sets, our tiles. So the Wang sets is the terrain. For each of the tiles, okay, so then for each tile we have an object group, and inside there is the, okay, so that's the tile ID. Then we have the geometries of the colliders inside. Okay, so this polygon of the rectangles are width and height. And these are tile. These are tile specific, I think. Yes, this is a tile relative coordinates. So we would then need to transform those. So each time when we load the map, we'd have to populate the world with the shapes. Okay. So, I think given this, we will need tile set. And then when we load the tile set, we load in the terrain data. So we would need to store the collisions. Okay. And then we also have these object layers. So what? Yeah. So the object layers are. So the objects not have drawing data attached to them, okay. So I guess that would be based on the implementation. We have image layers which will. So how do these image layers? Oh, sorry. So I was looking at the tiled earlier. I suspect, sorry, oh, I might have set up all of the, I think I just forgot to record all of the changes I made here. Fortunately, I will learn how to stream at some point, I promise. Yeah, so what we did is we applied in, oh no, yeah, I did, and then I switched back to our editor to look at how it came in, didn't I? Yeah, I was just having a look at, we have different types of layer here as well. So we have image layers. I think an image layer repeats an image. Okay, so this is like a background, I think. This is like for backgrounds and stuff like that. Or we want to put a weird image in the foreground. I think object layers are for us to specify where things are in the world. So what can we actually add to an object layer? So we can add different shapes, so points, ellipses, polygons. Okay, so we can set a tile, a collection of tiles, some text. Okay. Let's remove that for now. Okay, so yeah, so coming back to what we've got here, loading this stuff in. For now, we take the Wang sets and we set the terrain for the terrain for yes, sorry. At the moment, we map the terrains back to the tiles based on their tile ID. That's it. But we should probably actually start to extend the tiles themselves. So I think we're going to need a tile type. And then we'll need to store these collision pieces on them, on that tile type. Whereas at the moment we don't actually do much. We just take the atlas and we rely on the atlas, the index of the value within the atlas to be where we pull the tile from. So with that in mind, we're going to need tiles, which will be let's actually define our tile type externally. So we'll have a new file. What am I doing? Here we go. Yeah, new file. Tile.lure. As normal, go local m is equal to an empty table. Local mt is equal to index within that empty table, and return m. And we'll go function m.new local self is equal to a table, and return set meta table of self to empty. I have actually been wondering if we might be better off defining things more like that, but we'll stay consistent for now. Okay, so a tile is going to have an ID. This should be its index in the tile list. It should have the terrains and colliders. Let's go with objects for now. Yeah, I think. Okay. So we define this. We're gonna the ID is equal to the ID. Hang on, let's just get this bit working as it does now. So the trains is equal to trains. And so the trains equal to the trains, yeah. And then when we create the tile set, we'll have we'll have a field of tiles, and this will be of type tile. We will label this up, so this is a class. It's a class of tile, and it has a field of ID and a field of terrains. And we will go local tile equals require crawler dot engine dot tile. So tile class. And this is actually an array of tile. So we'll set tiles to an empty. an empty object. So I feel like, yeah, so this would be, so tiles would be an array of tiles. Mapping terrain patterns to indices. Okay, so I feel like then we actually lose the terrains from here. Terrains become set to that. Tiles is yeah, so we have ID and terrains. Maybe actually, yeah, we'll have index. Sorry, I think index is the right term here. So this will be the index within the atlas for the tile. And then we have the terrain for that tile. So these two will store, and then we'll generate the terrain lookup table in this method. So we'll go for, actually, sorry, we didn't actually keep these types, did we? So that'll be a number, and this will be, and this will be a 4-tuple, size 4-tuple of numbers for each of the corners. Maybe that. No, terrains, okay. Yeah, so this will be a 4-tuple of each of the corners. We will so we will need to loop over the Wang sets. So that's for each terrain type as well. Let's come back to this source again. So we've got these. So that we were taking the first value. In theory, we could define what a map could have different types of terrain though. And I can see now places where that would be useful in the future when we come to our generation. So So we make this a table of which terrain set? Yeah, I think so. If we have the number of the terrain set, then the terrain info itself. We can then we can store that here, and this is going to be a number, and we rename this to index, and this will be a table of the terrain set versus the terrain index versus the four corners. And then when we load the tile set, we can set a object here, and we will, for each of the one, then for each, so I think this is going to be type of table, and this will be number to table of number to so we'll have a table that will map and this will be the cell, this will be the tile ID, this will be the terrain index, I get the terrain set index, and this will be, oh, missing one there, and this will be the different, sorry, this will be the different corner terrains. Here, that will be the index of the terrain set, and this will be the index of the tile. So this will be let's call this the Wang index, and the tile, no, we still don't, okay, so we won't need an index there, but so if it is a corner, then if the type is corner, for each tile in the set, the ID will take the ID of tile ID. I think we actually need to increment all these tile IDs by one. Ah, okay, yeah, we do that here. Ah, okay, sorry, no, that's the, those are the tiles. So what we'll do instead is, for each tile, if terrains tile ID if that isn't set, then terrains tile ID is equal to an empty table, and then the and then terrains tile dot ID Wang index will be equal to a new table where we will go tile dot Wang ID 2 4 6 and 8 Actually, maybe we do just want to store the entire thing. So maybe wait instead, because I was just keeping the corners, but we can just expand this out to each number. So that should be correct. So in here we will also define an alias. Of terrains to be all of the values. We'll put that at the top of here, and then this will be to the trains. Hi, Captain Crumbs. How are you today? Today we're actually looking at some collisions in the engine. So at the moment we can move around with free rein and there's nothing to stop us moving. So we're reworking our tiles to support collision. And in part of doing that, we're making the tiles a bit more complicated. Is the game done yet? The game is not done yet, no. The game is a long way from done. Redefined local tile. Okay. Let's go with row instead of tile. That way we are not going to overwrite our global variable here. So yes, we have tiles get loaded in here. We're going to set this to the tile. We're going to create a big lookup table of the terrains, and then we will we'll insert the each of the tiles. So if we have, when we look at our tile set, do we have a, does this give us any info about the max tile? Okay. So we have tile count. Okay, so we have our tile count here. So 256 tiles. So when we load, we want to go to tile count. So for I is for I is 1 to data.tile count, incrementing by 1. We want to go sorry, we'll create an empty table for holding our tiles, and we'll go table.insert tiles, go tile.new, we'll call that index, and then in here we will go, we'll look for the terrains or an empty table. Oh, no, sorry, terrains is set, so it will be terrains. No, it should actually, we should be able to go like that, and then if we specify the terrains, yeah. Okay, so the terrains is the terrains. That's better. I will learn to pronounce things eventually. The terrains is a we'll look up by the index in our lookup table here, or we'll return an empty one. And then for our lookup table here, we'll go then we'll rebuild our corner table. Here we're going for tile in tiles do, and we'll if I guess we also want to have we'll also take a param of, we'll take a parameter of terrain sets. Field terrain sets is equal to what information do we actually have on these sets? We have a name. With the display tile. So we'll pass in the actual info about the terrains as well, I think. So maybe we won't actually get to the physics today. We might just end up beefing up our map to get us a bit closer to being able to get those values through. This is so. Probably don't actually need a separate thing for that, do we? Or maybe we do. Sorry, I'm just thinking about how we lay this stuff out. Okay. So we can have a concept. We probably don't need full classes for this. So these are going to be data, like just so we can use an alias. An alias is just a shorthand for a type. So I think we're going to have a terrain set. And that will be, and these are going to be sort of classes that don't really have any methods or anything on them. But the terrain set will have a name, it's a string, terrains, which will be a terrain itself. And this will have a terrain will have a name. So these both have a tile. This will have a number of terrains. I think we'll just have the tile set manage all of this internally. What else do we have on this then? We have a name. The name is potentially useful. we can keep the colors as well, I guess. Probability is probably not that useful. Color, which will be a the color is, so if we go back to the wiki, let's have a look. And so how, this is something we actually haven't looked at. How do the graphics part of Love2D, how does that represent a color? So if we find drawing methods, coordinate system, graphic state, object creation, draw. Graphic state, so set, get a color. How is this represented? Okay, so it's 0 to 1. It's RGB of 0 to 1, so this will be sorry, so this will be defined as 4 numbers. Okay, we only have 3, so that's fine. So and then for this we have the name. We also have a tile for those. We probably don't need it for the terrain set, but for the terrain, I think it's worth keeping the tile. So this will be terrain sets, which will be an array of these terrain set types. We'll pass these in at creation time. We'll store those, and then we'll have a terrain lookup, which will be a table. Yeah. So the terrain lookups, we will for terrain set X and terrain set in, iPairs of terrain sets do, and we will go if, oh, there we go. Self and terrain set lookups. We'll set the we'll set the index to an empty table. Then for index, for each item in the, we'll use item instead of tile because otherwise it's going to clash with the import above. So for each tile, we will go for actually, for each tile data, tile index for each terrain set index. Yeah, for each terrain set index, we will, our tile here, we have terrain. Hey Splash, welcome in. Welcome in. Sorry, I'm getting myself a bit lost at the moment in what I'm actually doing. So yeah, we need a lookup table of each of the. Sorry, so we need to build. First, we need to build that terrain's setup. Okay. Let's just call this what it calls itself. Try hard not to snicker at it. Okay. So we pass. Yeah, they whoever decided to well, I get it. It's named after someone named. His name will be something Wang, right? But the idea of Wang sets just. Why did the guy behind who built the tiled editor decide to go with Wang sets rather than terrains? It's let's go. Yeah, it's like of all the things they could have named it, and I get there's a valid reason for it to be called that, but it's still. Yeah. No, I 100% get why it's called that, but it's just no. So this one will go local terrain sets, and this will be a table of. No, this will be a terrain set. A list of terrain sets. So when we loop over these, if they are a corner one, no, dong sets would not have been a better name, Crumbs. But yeah, it's definitely not. I'm guessing the tool was definitely not created by someone who spoke English of an English persuasion. I'm not sure. I don't think it's actually. I don't think it's actually slang in America, right? Hopefully, someone will be able to point that out on the comments at some point in the future. Okay, so for so this has, see, some of the namings here is just weird as well, right? So it has a value colors. Within that is each of the different terrains. I think I managed to keep a straight face during the last time I had to deal with these, but yeah, no, I'm definitely not. I don't have my grown-up pants on today to to do the same. I pairs, so within the Wang set dot colors do so first thing we want actually is we're going to set our terrain set, and we're going to set it to have a name of the Wang set.name, and a terrains of an empty table. Then for each of the values in the colors, for each of the values in the colors, we will take the name and the tile, I think. So table to insert terrain set dot terrains, and we will add a new table, and that will have a name that is equal to might as well just go with the terrible naming scheme in here, shouldn't I? So a color, the color.name, tile will be the color.tile, and color will be I think we can do color, and we'll have sorry, color dot color. Yeah, color.color. And this will mean that if this is not set, then it will pick up a value, and we'll go for the first value divided by 256. So our current colors are in the range of 0 to of 0 to 256. Let's just double check that actually. So if we have a look at within our tiles, if we come to the terrain editor, if I add a fake one in here for now, yeah, it's within the range of 0 to 255. So if we export this temporarily with an empty one, what is it going to? What will it give us for our fourth? Okay, so it's going to go 0, 0, 0 for unset. Really? So for it just sets it to black. If I set it to green, okay, so it's not saving the alphas either. If we export it with okay, so it leaves out the last value if the alpha is set to 255. So yeah, if we set a random color here and export, and then we switch back, we can see that this is 255 for green, and then we get the alpha channel, but for anything else, there's no alpha set. So I think we will go, oh, no, it's not square brackets, is it? It's curlies. So this is the red, the green, and the blue values. We divide by 256 because that's sort of the base there. No, it'd be 255, won't it? Sorry, my brain is. It's the max value, not the full range. Yeah, so that'll give us the value for, so that's for 1, 2, and 3, and for 4 it will be 4. Or 255. So this will convert the it into a range of 0 to 1 rather than 0 to 255. Because tiled is using 0 to 255 to represent the colors, but Love2D will want 0 to 1. So this will give us that, and then this fourth value is only present when the others are not set. It's only present when it's actually set, so we'll set that one based on that, and then if we come back here, we can tidy up after ourselves and get rid of that extra. Export this. Again, and then when we come back here, yeah, so we've got the values that we expect, the names. I don't know if we need probability for the terrains. The tile is important because then we'll be able to visualize the terrain, a terrain map at a later date before rendering. So yeah, so that gives us I think this gives us a good representation of the terrain, and then that gets passed in. as our terrain sets into the instantiation here. And I think we can also we could probably make this optional as well, so we don't actually have to pass it if it's not available. Same for the tiles, I think. So we could, in theory, go not tiles. So this would support something akin to what we had before. Actually no, we'll leave the tiles as required for now. We can instantiate the tiles automatically from the atlas, so we can just go for every tile in the atlas we'll just set a tile with the index and no terrains, but we'll leave that there. And then for the terrain lookup, as I said, we're going to loop over the tiles for each terrain set. In the tile data dot terrains do, we will set we'll set a key to for each sorry, for each index and terrain, we will go, the key is we'll go on the corners, so this will be 2, we'll append that. These are, these. So if we go to put a colon, and there's 2, 4, 6, and 8. 4, 6, and 8, and then the last one we can take out the extra colon. So 2, 4, 6, and 8. So this is going to give us a value we can look up, similar to what we had before. Let me go. Then I think we want to go for if that doesn't exist, actually no, we'll just do that is equal to the no, sorry, the tile index, that's what we're after, isn't it? Yeah. Oh, sorry, self dot terrain lookup. Key is equal to that, and then there's, okay, so there's no value. Sorry, so we'll go if self dot terrain lookup of the terrain set index is, if not that value, so that will be, if it's not set, then we'll do, we'll say that that is equal to a new table. Then we want to set a lookup per terrain set. And then we'll have to modify our from terrain to pass in a actual terrain set. Local tiles for Y. Yeah, so then we're looking and we need to add our field here, which is the terrain lookup, which is a table of string to integer. Actually, there may be more than one matching tile, so I think we should probably look at that now ahead of time. So I think we'll look at see if the key exists, and if it doesn't, we'll set that as a table as well, and then we'll do table.insert of the table, and then we'll put we'll set that to the tile index, and then when we generate our terrain further down, for now, we'll take the first item. So I think local. Let's make this a little bit more real. So we'll go. We set the key there, and we'll set the key here the same. Put that on multiple lines as well. And then we could just break it up into the different pieces. I really do need to figure out how I keep triggering that. I click on something, I've never managed to fully work out what switches the blame mode on, but it's here. And there seems to be no way to actually turn it off in the settings from what I can see. Okay, so we've got our key. We've got our index. This is too wordy for it makes. There we go. So we've got, so if no table for the terrain set index exists, then we create one. And if we don't have one for the key that we generate from the four corner terrains. So as this, we create that as well, and then we insert a tile, and then down here we pull the first tile that we found out, and set that if we're generating the tiles from the terrain. So this will allow us to generate our sort of offset grid of the different tiles. At the moment we'll pull the first one. So we should have one of these per terrain, so we might not necessarily have the key. So I think we'll need a little guard here, so that it's not trying to look something up on nil. Is that there? Then when we load the tiles, the tile set, sorry. Where do we read the tile data itself? So we insert these, but hang on, one other thing we'll need to adjust is so these IDs will be 0 based, I think. Yes, these are 0 based. Oh no, wait, they're 1 based? Okay, so that, yeah, and then this is so our first our tile 1 has grass, which is the second item. So yeah, okay, so this is getting these are correctly translated across. And then our data, we have that will be 0, I think. Yeah, and then when we're drawing things, 0 represents our our non-existent tile. So we have, let's see if things are still working. That would be a no. So tile set lure on 1, 1, 1. Okay, so that's it. Says table index is nil. So for each of the Wang tiles, it's tile ID. So these These are all off by 1. So our tiles themselves, I think the IDs are going to have to be incremented by 1. Yeah, okay. So we've, well, this is tile ID. Sorry, yes, we did have that in the original code, didn't we? So the tile ID is incremented by 1. Then when we create that, we get our tile IDs. Sorry, we get our terrains. Let's run again. Okay, so we've got, things seem to still be working. Let's also have a look at when we instantiate the tile set itself. Here. So if we put a breakpoint there and we run the game, what do we get in our values? So self, we have the terrain sets, which is a list of, which is length 0. Okay, that's not correct. And we have no tiles. So something has gone wrong. So let's stop that for now. Let's have a look in the load method and see what we're getting here. So if we run again, so the terrain sets to 0. So we definitely got things in the Wang lookup table. Tiles is a array of 256 items. And it's getting the identifiers attached to them. Okay, so that bit seems to be working. But the terrain sets are not getting set. So we instantiated that here. Okay, so we set up the terrain set here, but we don't actually then add that to the table. So so actually we want to ignore this here. Here we go, terrain, we'll go table.insert into our terrain sets, the new terrain set itself, and then the local Wang index will be the length of the terrain sets, because this table is going to grow, because we're going to skip over anything that isn't corner based, I think. Yeah. So we'll skip over anything that isn't corner based. And then when we run, we have our terrain set there, we have our tiles, we have our atlas, and then if we carry on, we get a new error. It's line 42. This is as part of our loading. So as part of our creating things, so we have a quick so this is index is so line 41, yeah. We have it's because I'm using the wrong value, so yeah. It should be terrain lookup, and I'm using terrain set lookup in that bit there. This should all be, I think that was the only instance we had it wrong. And when we look it up down here, yeah. Okay, so run again. And now when we look at the self, we have our terrain lookup table. That has one, and then that has all of our mapped corner terrains onto tables, and each of those has, okay, some of these have, so the ones that have all of the same type have a couple of overlap ones. So this will have one, this one will have two. Okay, so it looks like our terrain is being loaded correctly. So if we take out the breakpoint and continue to run, yeah. So we've got our map loading with the terrains, and that's all powered by this tile object now. So now we can extend the tile object to have the geometry from the collision. Yeah, the map is, I'm quite happy with the map now. So given the work from last week, actually being able to move around and having it like zoomed in a lot more, we don't seem to be getting any weird sort of stuttering of pixels and things. We now just need to solve this bit so we can't just wander into the water. But yeah, it's coming along nicely, I think, and it feels quite smooth. I do want to add some stuff that, so I want to try and smooth the camera out a bit. So at the moment, as soon as I press the key, the whole camera starts moving. Whereas what I've noticed with a bunch of games is, especially from like a top-down perspective, that it tends to look a bit better if you get a little bit of slack. So like, if I was just stood here, I'd be able to sort of move around like this without the screen moving. But then if I move too far up, then it starts scrolling. So it's like the camera sort of drags behind a little bit. So I want to try and add that into our camera. I did try and do it the other night after the previous stream, but it was getting a bit hairy and I wasn't able to get it working as well as I was hoping. But I might have another crack at it soon. But I wanted to, I'd sort of had enough of cameras for a little while though, so I thought I'd try and we'd come back to our maps for a bit and try and get some collisions in, and then we'll try and get some physics in as well. So we're all done with the wangs now, I think. Now I think it's time to look at the objects. Yeah, it's bad, isn't it? It just doesn't get old. You think that age would bring sort of maturity or whatever, but it really doesn't, does it? Okay, so let's have a look at the collision editor. So these, we seem to have object groups in the editor. Sorry, in the output. So can I group these? Can I create a group? So there's a template, there is polygons, ellipses, points, editing, selecting. Okay, so it looks like that we get an object group for each tile. But we get one group. So so each of these object groups, I think, are they're offset to 0, 0. Okay. So is this the no? But that's the tile properties. How do I get to like the? So I can't actually interact with that that parent one at all. So I get the width and the in the edit. I can't interact with this object at all in the editor. So draw order index. So we have. So all of this is effectively pointless data, and it's the objects within it that we actually care about. And within those objects, they can be polygon, rectangle for a shape, for the shape. Or I'm guessing ellipsis and point as well. Or template. So I want to try and pull these shapes into the collision detection so we can sort of prevent the player from moving outside of them. Outside of the world. So I think what we want is let's call them colliders maybe. Sorry, just trying to think how we structure this. So hang on. Okay, so these are effectively a shape, visible, X, Y. I'm just wondering if there's anything extra in the logic. So if we let's go back to the physics module and see what these best map onto, and that we'll use that for our naming, I think. So there is a shape, and this has the, so there we have a polygon shape, for instance, circle shape. I guess the rectangles will be a polygon shape with the same, just with the corners as the points. Okay, so this is up to 8 sides. What have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's that out the window already. Let's just have a new polygon shape. Shape can have 8 vertices at most. Yeah, so we've we've gone and screwed that up already. So we have what, 10 here? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 vertices on this one. So we will have to go back to our the tile editor. We're going to have to make sure that all of these are simple shapes. I think the ones where this is going to be a problem is these ones. Yes, this is where problem is, I think. So it'll be this one and this one, I think. So we'll have to define the borders on this using less than 8 points. So this one is 1, 2, 3, 4, 5. Yeah, so these ones are okay. But we're going to have to define these as separate, multiple shapes. Okay, so if we insert if we go for polygon, oh, sorry, yeah, if we go for polygon of insert point, insert polygon, we want 8 sides max, 1, 2, or 8 corners max, 1, 2, 3, 4, 5, 6, 7, 8, and then if we do another one, we want 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that should work, I think. Let's we should be able to edit these as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So is that actually halfway? Can we... Here, let's try and make them a bit straighter rather than overlapping too much. So rather than trying to make things marry up on a diagonal there, I suspect that will have some fun rounding issues. So yeah, okay. I think that kind of works. Maybe we want to move these points over slightly, and these ones. Oh. Right, that's one, and then we'll look at the other one, which is down here. Trying to give it the same, yeah, we'll try and give this the same treatment. So we'll go with the polygon, and we'll go 1, 2, 3, 4, 5, 6, 7, and 8, and then if I set this to 16 by 16, I can see where the edges are. Yeah, and then we'll try and find a border along there. along there to align things on. And we'll take another polygon and we'll go around like so. That'll give us another eight cornered polygon. We probably want to go over a bit on these. Yeah. Okay, that looks okay as well. We'll export. And now if we come back to our tiles, yeah, so now we have 1, 2, 3, 4, 5, 6, 7 points in there, and okay, yeah, 7 in this one. But we have 2 separate objects for our shape, for our object. Yeah, and this one. Interesting. Okay, the alignment on these is a bit. The X and Y is a bit weird, so it's all relative to the first point. Okay, so if we take that, we now have a polygon, shape polygon. We have the X and Y width, height is not set. Rotation. I don't think there's any rotation in this in the editor, so I think from this we want to then create a shape effectively. So if we go to the tiles, sorry, tile.lua, if we set an alias of I think let's create a new class. So we have our rectangle to represent the rectangle types. We have our vector2 to represent the points. We don't currently have a circle, an ellipsis type, or a polygon type. So we can have, if we add a poly2 .lua, we only need rectangles and polygons for now. So m is equal to an empty table. Empty is equal to table index set to m, and then we return m. This will be a poly2. Maybe we'll have it poly. We will call it a polygon2 instead. Okay. Function m.new is equal to. Sorry, function m.to and local self is a table, and we'll return set meta table self and empty, and in this we'll have we need to take the indices of the shape. So that would be an array of vector 2's. Is that right? So, yeah, I think we'll have indices, and this will be this is spelled wrong. Fix. Here we go. And that will be a vector 2 array. For now, we will import the vector 2 module types. Indices. Yeah, that. And then we'll store the indices on self. I think that will do for now. We can add some extra methods on this later, so we might be able to add some methods to. There's some maths we can do to work out if something is inside or outside the shape. We'll also get we can add some stuff to get the bounding rectangle and stuff, but we don't need that at the moment. We just need to be able to create them. So when we are loading our tile set, we next want to load the collision objects. So is it colliders? No. Yeah, so I think we'll add colliders, and then we will import here we'll add the rectangle. So we want our rect 2 and our polygon 2. That'll give us those two types, and our collider param what's my plan now when I don't have a schedule? Yeah, so my schedule is going to be a bit wide open for a couple of weeks, so as I put my notice in on Friday, and we'll be finishing next Friday. So it's going to be wide open for a bit, but only for a couple of weeks, and then I'm going to be starting a new company with friends. Which is equal parts exciting and scary at the same time. But yeah, so I will be starting a new company, and well, in the gap between that, I guess there will be a lot of there'll be a bunch of Minecrafting, as that is that's effectively the way that Minecraft and other games, because that's the way that I decompress. And a break between jobs is basically there for decompressing, right? So yeah, this will be. I'll have 2 weeks, and the plan so far is there will be some sitting in my pants playing computer games, some sitting in my pants watching TV, some sitting in my pants watching TV while playing computer games, some sitting in my pants while sitting in my pants and playing computer games while watching TV, and then very occasionally I might actually put proper human clothes on and do a stream. But yeah, that is basically my agenda for the couple of weeks following my final day. Okay, sorry. So we've got the colliders. We'll say that's a rectangle or a polygon. And we'll have a list of them. So when we loop over things here, we're going to want another. I think we can also make this optional, so we can pass nothing in there. Yes, the colliders will create a table, and then we will go for where is our file gone? Okay, so for in pairs of, and that was data.tiles, just to double check. Yeah, data.tiles, so we're going to have one of each, and each of those is going to have an object group. So for each of those, we want to go colliders, colliders ID. So the first ID we have is 4. Let me just check our tile set to make sure that, yeah, no, it's doing the weirdly offset tile IDs again. So 1, 2, 3, 4, 5. Yeah, so this is actually describing oh, hang on, I've lost it again. Yeah, so this is actually describing tile number 5. So we want to go maybe it's actually the tile it describes though. Okay. So tile data.id plus 1 is equal to an empty table, and then for objects in iPairs of, okay, so we have this, so we're going to object group dot objects. So tile data dot object group dot objects. We want to go, and then we go if object dot shape is equal to rectangle. Where is a rectangle? Here we go. Yeah, then we want the x and y and the width and height. Then table dot insert colliders. Into that one, we want to add a we're not actually importing our rectangle here. So rect2 is equal to require crawler.engine.rect2 and then we have polygon2. So polygon2 so we now have our two shapes. Where were we loading those? Yeah, so this is going to be a just for our own sake, we're going to have a type. This is going to be a table of number to rect2 or polygon2. No. Yeah, it's going to be, sorry, it's going to be to a table mapping to a list of rect2 or polygon2. So we'll add, yeah, so we create the table here, and then we'll insert the items as we loop over them. So this is a rectangle, we'll go rect2.new, and this will be object.x, object.y, object.width, and object.height. So this is over quite a bit here, isn't it? Okay, let's spread this out into 2 lines. Okay, so we've got a rectangle there. Else if this is a polygon, then we want to take the polygon, and this will have the x and y's. So create a array of vectors. So this will be the same as above, but it'll be polygon 2, and we'll have we'll pass the vectors, and then we'll need to loop over each of the items. So for point in object.polygon, then, oh no, that's wrong. So for each point in the polygon, we want to go vectors dot insert, no, sorry, table dot insert vectors, vector 2 dot new point dot x and point dot y. So that gives us, that should load the shapes in. Yeah, so that should load our shapes into our various classes. Okay, I think that should work. Oh. So we have support for a rectangle, we have support for a polygon. So then when we create the tiles, we then go colliders index, and that will give us any shapes that are attached. So if we set a breakpoint here and we run the game, no, we didn't get to that breakpoint, we hit a problem. So it says tile set on 155. Tile set 155. Oops, sorry. We put this outside of the thing. It wasn't actually calling the right method. Okay. So when we look at our tiles now, so if we look at tile 5, for instance, it has a table, length 0. Okay, so we have a table of length 1 here, and this is okay. So this is a rectangle. Why do we not have an item? So why did our polygon not get added? So we definitely create it. That's why we had polygon 2 instead of polygon. Sorry, so if we try this again, we now have a error on line 139. 139, okay. Sorry, so we forgot to wrap this in I pairs. Let's give it one last go. Here we go. And then if we look at tile number 4, tile number 5, terrain, and this is sorry, no, that's terrains, isn't it? We want colliders. That's one. So we have length 1 here, and we have the indices, okay? And then we have our vectors, 5 vectors for the 5 points on the border there. Okay, so I think we have the shapes now. Let's just test everything works as well. So we'll take this breakpoint out. Yeah, we haven't broken anything, so this is still working. The next step, I think, is we're going to need to be able to populate the. We're going to need to be able to populate the we're going to need to be able to populate the physics world from the tile layer. So I think we'll need to be able to get the shapes for individual tiles, but offset relative to the X and Y position of the tile, where the tile is placed. So we might need to add a method to each of these types to move it. Function m dot let's move the right term. Actually, I don't think we need to do it for the rectangles, because we can just update the position and the width and height will match. But for the polygons, we'll need to move it. So I think in this case, we might want function m dot move. No. I don't really like that term. That term for it. Sorry, I'm just trying to process what we're actually trying to do with this. I think if we, I think offset is maybe what we're after. So offset will be self and position. No. Self and offset. There we go. And then we will offset actually this is that will be a delta, which is basically just a fancy word for a difference. Delta will be a vector 2, and we will return a polygon 2. Here we go. Naming things still remains the hardest thing in programming. So our offset is going to be, method is going to update all indices add delta to all indices. So we'll have a local indices is a table, and then for vector in self dot indices do, and we're going to go table dot add vector plus del to our indices. Sorry, it's not add, is it? It's insert. Yeah, so we're going to add, we're going to insert the new indices, and we're going to loop over each of the existing indices, and we're going to add the updated one to our table, and then we're going to return m.new with the with our new set of indices. So this will give us a polygon that's been offset by this delta. And I think for simplicity's sake, we will also come to our rect class, and we'll do the same here. We'll offset the rectangle. This will be a rect2. And in this case, we just want to go return m.new and it will be self.position. Oh, local position is going to be self.position plus delta. And then this will be position.x, position.y, and self.size.x and self.size.y. Sorry, I do not need that anywhere near as wide as it was. So yeah, so so we're going to update our rectangle, and if we're just going to move its position, because only the position coordinate really determines where it is, and the width and height will stay the same. And yeah, that will give us that will put the shape in a different place. That will allow us to move these shapes. So then when we have in our tile set, we go function, we go get colliders, m.get colliders. And in this we'll take self, tile and a tile index, an X and a Y. So this will be a number, actually no, position. Position, this will be a vector2, index will be a number, and position will be a vector2. Okay, so when we get those colliders, we can then go tiles index, for collider in so for each of the colliders, sorry, where's the method gone? Sorry. So for each of the colliders, we're going to want another temporary local colliders table. We'll insert into the colliders. Collider.offset. And then we'll get a pixel position, which will be position times self dot. Do we have the tile size on the? We do not store the tile size on the tile set. We probably should. So we should probably actually store the tile size on the tile set. I'm going to add that as a tile size is a vector2. Yeah, we shouldn't have to go through the we can actually rewrite this here. Sorry, distractions. That to yeah, so we can just increment our way through the indexes instead, and that should be quicker than looping over each item. So yeah, so where is our get colliders gone? Yeah, so this is then times self dot tile size. So we'll get the we'll get an offset for each of the vectors. So for each of the polygons or the rectangles, we'll offset it by the pixel position of the tile. And that will give us I guess we don't even need the old position, so we could just actually no, let's call it offset. There we go. So we'll get a table of each of those things, and then we'll return the colliders back. Yeah, I think that's a and this will return rect2 or polygon2. Get colliders for colliders, and this will get the for the select tile updated with the tile position. So now we should be able to get the colliders out in our tile layer. We should be able to add a function here. Initialize. Add. Add physics bodies. So I've tried to keep this and follow like the Lua convention that the language itself sets of just mashing the words together. It's starting to upset me. And then when we look at all of the methods from Love2D, like they have basically just abandoned what the language itself does and gone for camel case for everything. And I'm starting to think maybe it's time, maybe I want to follow suit. So I think okay, it's going to be a pain in, it's going to be a bunch of boring work, but I think off camera I'm going to go through everything and all of our methods, all of our classes, etc. We're going to name our classes camel case, and then we're going to name all of our methods the same with sort of lowercase camel case with a lowercase first character, and we're going to go with a standard sort of. We're going to go with a standard naming convention because pretty much every other language will use either this or it'll use what's called snake case, which will be underscores between the words. But both of them make things that are readable, and this is getting to the point where it's not readable anymore. Okay. After that rant, let's see. So we're going to update the world, and this is going to be a love dot world. We're not going to return anything. So for so I think this will work the same as the batching. So we're going to want shapes. For so for the matching for index and tile in data. So for index and tile in self dot data, do we've got the basic logic for calculating the x and y based on those values. So set the colliders to self.tileset.get colliders. Tile and maybe we actually just pass the width and the height directly here rather than keep instantiating vectors. Yeah, I think for the get colliders we will actually no, because we're using the vector elsewhere. So local offset is equal to vector2.new Okay, that's the first time it's been smart enough to suggest the offset for us. Sorry, to suggest the includes for us. Okay, so we want tile size.x. Yeah, so we want to take the index -1 times the divided, well, we want to take the remainder of index -1 divided by the no, it's the layer width we want. Layer size, that's the one. So yeah, we want the we want to take the modulo of layer size the modulo of index -1 and the layer size x, which is the width, and then we want to take the rounded down value of index -1 divided by self.layersize.y, which is the height, and that'll give us our offset of x and y, and then we can get the colliders for that. And then we want to world love.physics dot new body world we want an x. Okay, so maybe we don't actually need to offset the values. Okay, I think this makes sense. So we don't actually need to do this offsetting. So we can take that out because the physics library will do all of that for us. So for the tile set, when it comes, get colliders. So we don't need those. So we can go, don't need that either. So the colliders will be tile set, tiles, then we take the tile, and then we've got colliders. That's because that's not on it. So that we can add our colliders, and that will be rect2 or polygon2, and that is an array of those two types, or a list of those two types. Cool. So that should now be visible here. So we've got our colliders. For collider in, we could probably just iterate over those actually. So we can loop over those. So I think we need to create a new body. So the body will be here. We need an X and Y for that, which will be the maths of so local X is going to be index -1 modulo the layer size dot X and then all of that is going to be timesed by the tile size dot X. So that'll give us our pixel X position. Y will be index -1 divided by self dot layer size dot Y, and this will be floor of that times self dot tile size dot Y. Then we also have an offset on the layer size, don't we? So plus self dot offset dot X, and this will be plus self dot offset dot Y. So this is X is equal to the index -1 modulo that times the, yeah, that's a little bit more readable. And we'll do the same with this one. Oh. So we get the X and Y, we get our X and Y positions. We'll create a new body. So this takes the X and the Y. And then we need to give it a type. So I think it's a static for these. And then for each collider, do we then create a shape? Just a quick look at the physics module docs again. So we have a body. I guess we have to add a shape as well. Okay, and the shape will be different depending on which we create. So for polygon shape, create with new polygon shape, and that takes a list of X and Y positions. Okay, so if we have a look at our poly, we have the rect. So we need to unpack these into something that could be passed into the physics methods. So our rectangle one, I think we can go function m dot indices self, and then we go local left top right bottom is equal to self.edges, and then we can return left top right top right bottom and top, sorry, and left bottom. So how do we express a verdict, sorry, a vararg return. So let's have a look for how we type things. Okay, returns. Variable function returns. Okay, string dot dot dot. Yeah, so I think what we want here is like that, and this will be return the indices, the unpacked this can conflict with no, I think I'm just adding mess to the rect class for this one use case. So I think what I'll do instead is what we are missing though is a rect method. So self and we'll return meta table self is equal to our meta table, and then we'll have the same for the polygon. So is polygon, that'll do the same, and then in our tile layer we will in our tile layer we'll have if no, that's added wrong. Okay, so if rect2 dot is rect collider, then if it's a rectangle, we'll go local shape equal love physics dot new rectangle shape, and in here we'll go so we can't actually okay, so so then we want collider.x collider.y. Oh, sorry. Collider.position.x. Collider.position.y. Collider.size.x and collider.size.y. And then this will set I'm not very accurate with my key combos today. And then if else if polygon 2 dot is polygon. Did I not? Yeah, it's polygon. So okay, let's add the pot. See, I thought I was impressed for a while there. I thought it's actually been useful, but it turns out not so much. Okay, so if it's a polygon, then so we'll get that, and then we'll go. So we define the shape. How do we add it to? So I think I'm probably going to call it here because it's been going. We've been going a good 3.5 hours now. So I think I will. Yeah, I think we'll finish this. We'll finish this next week, and hopefully at that point we'll be able to get at least load the various shapes from our map into the physics engine and see how that works out. So if you'd like to see that, then make sure you're subscribed to the channel, hit that notification bell. If this has been interesting in any way, then hit the like button. Yeah, 3.5 hours is a long time to be focusing on anything, I think. Plus it's 5:30 here, which is basically dinner time, and I need to go and eat, as my brain is actually starting to. I can feel the energy in my brain just draining away through the lack of food. But yeah, so we'll come back to this next week. Fresh eyes. We'll finish it off. We'll get the physics. We'll load all of our the shapes of our tiles into the physics world, and we'll see if we can get that rendered out and see if we can get some barriers in so that the player can't just move around freely. I think that'll be a good place. And I think we've basically done a lot of the prep work this week, and then next week we'll actually be able to confine the player into where it can and can't walk, and I think that will kind of be the start of having a good game. So yeah, like an actual functional game. So if you have liked, like as I said, if you've liked what you've seen, then make sure you're subscribed and you've hit the notification bell, and I will see you next week for the second part. Give the channel a like. If it's been at all helpful or interesting. can join me on my Discord, which I will post in the chat, and is also available in the video description. And if you'd like to talk about anything, and I will be back at the same time next week. And if you're interested in some gaming streams, then I will be streaming some Minecraft Skyblock on Wednesday at 10:30 a.m. UK time. So until then, goodbye, and yeah, I will see you all next week.